y comma z and x comma z. So we will check for the condition for transitive. So I will show you this with an example. Let's say for example a father and son. Here f is father of s, so f will be father and s will be son. Okay, so here I can tell x is father of y, so father will be x and son will be y. And the next condition for the transitive will x comma y belongs to r, then y comma z should belongs to r. That is y is father of z. So I can write here as g. Now g is son of s and s is son of f. Okay, so the third condition will be x comma z, that is x and z. So now what happens, x will be a grandfather of z. So but the condition should be x should be father of z, but here the relation is becoming x is grandfather of z. So now this relation is not possible, so this will become not transitive. Sorry, this one is reflexive. Okay, so now we will go with the next question. That is second question. Show that the relation R in the set of real numbers defined as the relation is given by R is equal to a comma b and a should be less than or equal to b square is neither reflexive nor symmetric nor transitive. So we have to show that this is not reflexive, this is not symmetric and this is not transitive relation. So how should we show this? We will show this with an example. R is equal to a comma b. A is less than or equal to b square. So we will take an example. Let me take a as 1.2 and b as 1.5. Okay, so for the reflexive I have to take both should be same, that is 1.2 and 1.2. So if we check 1.2 and 1.2 with the condition, here the a will be 1.2. If I take a as 1.2 and it should be less than or equal to b square, that is b I am taking it as 1.2 b square. So 1.2 should be less than or equal to 1.2 square will be 1.44. Correct? So 1.2 is less than or equal to 1.44. So this condition is feasible. But we have to check for the other examples also. So the other example I can take as in decimals. Let's say for example 1 by 2 comma 1 by 2. So for this condition, when I take a as 1 by 2 and b as 1 by 2, so I'll do 1 by 2 square will be 1 by 4. So now if you apply this condition, 1 by 2 should be less than or equal to 1 by 4, but here this condition is not possible because 1 by 4 is less than a, less than 1 by 2. So the relation is non-reflexive. Similarly, I can check for the next condition, that is symmetric. So let me take an example. I'll take 1.2 comma 1.5 and 1.5 comma 1.2. See, for the symmetric, this condition should apply, that is x comma y belongs to R, then y comma x also should belongs to R. So now I am taking A as 2 and B as 1.5. So as per this condition, so when I take A as 2, this 2 should be less than or equal to B square, that is 1.5 square. So 2 should be less than or equal to 1.5 square will be 2.25. So this condition is true. Why? Because 2 is less than 2.25. Now we will check for the next. Here the A is 1.5 and this should be less than or equal to 1.2 square. So 1.5 should be less than or equal to 1.2 square will be 1.44. Now check. Here 1.5 is not less than or equal to 1.44. So you cannot write 1.5 comma 1.2. This is not possible. So now we can define that the relation is non-symmetric. Next condition, that is transitive. So I can write 2 comma 1.5 and 1.5 comma 1.2 and 2 comma 1.2. So let me take this example. So for the transitive, A comma B, B comma C and A comma C. This condition should apply. So I am taking A as 2, B as 1.5, D as 1.5 and C as 1.2 and A as 2 and C as 1.2. So let's check whether it is transitive or not. So when I take A as 2, this should be less than or equal to 1.5 square. So 2 is less than or equal to 2.25. Yes, the condition is true. Why? Because 2 is less than 2.25. Check the next condition. That is 1.5 should be less than or equal to 1. So let me take 1.3. So we'll change this as 1.3. Okay, so 1.5 should be less than or equal to 1.3 square. So that will be 1.69. So even this condition is true. Why? Because 1.5 is less than 1.69. Next condition, we'll check. A is A is 2 and C is 1.3. So here C should be C square, that is 1.3 square. So 2 should be less than or equal to 1.69. This condition is false. Why? Because 2 is greater than 1.69. 2 is not less than 1.69. So this condition is false. So 2 are true but the third condition is false. Then we can write this as non-transitive. Okay, fine. Now we will go with the next question, that is check whether the relation R defined in the set 1, 2, 3, 4, 5, 6 as R is equal to A comma B and B is equal to A plus 1 is reflexive, symmetric or transitive. So here we have to check this relation. Is this reflexive or this is symmetric or transitive? So we will start checking the relation. Now the set is defined as 1, 2, 3, 4, 5, 6 and relation is A, B and B is equal to A plus 1. This is the relation. Now start defining the relation. So when I start defining the relation, you have to give one value for A and one value for B. So let me take okay. So first condition we will check for the reflexive. So for reflexive we should give if A is 1 and B should also be 1. So when I take A is equal to 1 and also B is equal to 1, but this condition should apply, that is B is equal to A plus 1. when I take A is equal to 1, B will become 2. Correct? So when B is become 2, I cannot write 1 here. So if I take one more example, let's say for example, if I write A as 2, for the reflexive condition, B also should be 2. So if I take A as 2, 2 plus 1 will be 3. Now the B will become 3. So this should become 3. So you cannot write 2 here. So these conditions, so this 1 comma 1 and 2 comma 2 relations you cannot obtain from this condition. So this will become non-reflexive. Next, we will check for the symmetric. So for the symmetric, let me take A is equal to 1. So when I take A is equal to 1, what is B value? B is equal to A, that is 1 plus 1, that is 2. I will write B is equal to 2. For the symmetric, what we should get? We should get 2 comma 1. So we will check whether we will get 2 comma 1. Here A is equal to 2 and B is equal to 1. So when I take A is equal to 2, B is equal to 3, that is 2 plus 1, it will become 3. So when I write 2 here, I should write 3 here. You cannot write 1 here. But for the symmetric, you need 1 here. So you cannot get 1 from this condition. So now what happens? This will be non-symmetric relation. Next relation, next condition, that is transitive. So when I take A is equal to 1, B will become 1 plus 1, that is 2. Now if I take A is equal to 2, B will become 2 plus 1, that is 3. Okay, so for the transitive, what we should get? We should get these two values. A is equal to 1 and B is equal to 3. This one we should get. Check whether we will get this. I have to take A is equal to 1. So B is equal to, if I take A is equal to 1, then B will become 2. But for the transitive condition, I should get B value as 3. But I cannot get B value as 3. We are getting it as 2. So this condition is not possible. So we can write this as non-transitive. Okay. So now for the third question, we can write the relation is non-reflexive, not symmetric, and also non-transitive relation. Now we will go for the fourth question, that is show that the relation R in R defined as R is equal to A comma A and A should be less than or equal to B is reflexive and transitive but not symmetric. So how should we show that? So we will go for the fourth one. See, for the fourth question, they have given a relation R is equal to A comma A. A should be less than or equal to B. So to show this as this is reflexive relation, you can take any number. Let's say for example, I am taking A as 1, B also as 1. So for A as 1 and B as 1, check this condition. A is 1, it should be less than or equal to 1. B is also 1. So is this possible? Yes. Why? Because 1 is equal to 1. So I can write 1 comma 1. Similarly, you can take any number 2 comma 2 or 1.1 comma 1.1. So when you take all these numbers, you can check with this condition. 1.1 will be equal to 1.1. So this condition is possible for the reflexive relation. So from this example, we can write that the relation is reflexive. Now what I should show? And transitive. Okay, so now I'll check for the symmetric. For the symmetric relation, if I take A value as 1, B values B value I can take 2, because B should be greater than or equal to A. So I am taking B, it is greater than 2 is greater than 1, so I am taking it as 2. Now the next condition, I am taking A value as 2 and B value as 3. So even this condition will apply for this, that is 3 is greater than 2. Okay, so to check for the symmetric, I should get, if 1 comma 2 is there, then 2 comma 1 also should be there in the relation. So can I get 2 comma 1? See, if I take A is equal to 2 and B is equal to 1, the condition is A should be less than or equal to 1. Here 2 is not less than 1. 2 is not less than or equal to 1. 2 is greater than 1. So this condition is not possible. So this is not symmetric. Now the next condition is transitive. So to define the transitive relation, let me take A as 1 and B as 2. And for the transitive relation, I will take A as 2 and B as 3. Here 3 is greater than 2. Again, for the transitive, I should get 1 comma 3. So can I get 1 comma 3? Check this condition for 1 comma 3. Here A is 1 and B is 3. And 1 is less than 3. So this condition is applies for the transitive relation. So we can define this is transitive. Now we'll go with the next question, that is fifth one. Check whether the relation R in R defined by R is equal to A comma B and A is less than or equal to B cube is reflexive, symmetric or transitive. Okay, for this fifth question, we have to show relation, we have to check the relation whether it is transitive, reflexive or symmetric. So we will check this with an example. Let me take, if I take R is equal to 2, let me take 2 comma 2. Here A is 2 and B is also 2. So I have to check this condition for A is equal to 2 and B is equal to 2. For this condition, A should be 2 and B is also 2 cube and 2 is less than or equal to 8. Okay, so for this example, this condition will apply. But the set is set of all the real numbers. I have to check for the decimal numbers also. When I take 1 by 2 comma 1 by 2, I have to check this condition. Here A is 1 by 2 and B is also 1 by 2. So A should be less than or equal to B cube. So just solve this equation, less than or equal to 1 by 8. So 1 by 2 is not less than 1 by 8. 1 by 2 is greater than 1 by 8. So this condition doesn't apply for the reflexive. So I can define this as non-reflexive. Next, I have to check for the symmetric condition. See, for example, when I take A as 2 and B as 1.5, for the symmetric condition, I should get 1.5 comma 2. Okay, so I'll take A as 2. From this, A is 2 and B is 1.5. This should be less than or equal to 1.5 cube. So 2 is less than, so what is 1.5 cube? Let me do the calculation. it is 3.375. So 2 is less than 3.375. So this is possible. Next, for the symmetric 1.5 comma 2, that is A is 1.5 and B should be 2. So when I take 1.5, it should be less than or equal to 2 cube. And even for this, 1.5 is less than 8. But we will check for the decimal that is below 0 values. So when I take, so let me take an example of 1 comma 2 and 2 comma 1. See, apply this condition for this example. A is 1 and B is 2. So A should be less than or equal to 2 cube. So here 1 is less than 8. So this is true. Now check for the second condition. A is 2 and B is 1. So 2 should be less than or equal to 1 cube. This condition is false because 2 is not less than 1, 2 is greater than 1. So this is false condition. So first condition is true and second condition is false. So this is non-symmetric. Now check for the last condition, that is transitive. So I'll take relation A as 2 and B as 1.5. Now the next condition, I'll take 1.5 and 1.3, and the third condition will be 2 comma 1.3. Let me check. Okay, let me take this as 1.2. So first condition, that is A is 2 and B is 1.5. A should be less than or equal to B cube. That is 2 should be less than or equal to 1.5 cube. And 2 should be less than or equal to, what is 1.5 cube? 3.375. The condition is true. Check the next condition, that is 1.5 should be less than or equal to 1.2 cube. That is 1.5 should be less than or equal to 1.2 cube is 1.2 cube is 1.728. So this condition is true. Why? Because 1.5 is less than 1.728. Now check for the next condition, that is 2 should be less than or equal to 1.2 cube. So 2 should be less than or equal to 1.2 cube is 1.728. So this condition is false. Why? Because 2 is greater than 1.728. 2 is not less than 1.728. So in this case, two conditions are true but one condition is false. So we can define this as non-transitive relation. Okay. So we will start solving the questions from 6th in the next video. So please watch the complete video for better understanding, and thank you so much for watching the video, and please don't forget to like, share and subscribe to my video.